Hello there, Mr. Sutton here, bringing you the AB Calculus 4-2 Extra Practice Number 5 solutions on increasing and decreasing intervals. On this problem, I'm trying to find the intervals where this function is increasing and decreasing. To do that, I'm going to take a look at the behavior of the derivative. So let me take f prime here. That's going to require a chain rule. Our outer function is e to the something. The derivative of that is also e to the something. But we have to multiply by the derivative of the inner function as well, which is 2x. And now, specifically, when I take a look at the behavior, I want to set this thing equal to 0, find critical values, and figure out where f prime is positive or negative. So setting all this equal to 0, we know that e to the x squared minus 1, since it's an exponential function, cannot equal 0 at any point, but 2x can equal 0 if x equals 0. So let's put that critical value on a number line, an f prime number line, and see what happens. So there's our critical value. I'm going to test something less than 0 now, like -1, and I'm plugging this into the derivative. So let's see here. We know that e to the whatever has to come out positive, because again it's exponential with a positive coefficient there. 2x then determines the sign of this thing completely. If I plug -1 in for that x value, that makes this whole thing negative then. And let me test something bigger than 0, like 1. Well, 2 times 1 is a positive number as well. So because my f prime is positive over here, f is increasing from 0 to infinity. And because f prime is negative up until 0, f is decreasing from negative infinity to 0. For this problem, we have an f function that's continuous on a closed interval from 0 to 5. And we're given the graph of f prime right up here. Based off of this, we want to know on which intervals f is increasing. So we know that f is going to be increasing wherever f prime is positive. Looking at the graph here, we see that f prime is greater than 0 on the interval from 0 to 2, and also from 4 to 5. Therefore, f is going to be increasing on those same two intervals, which gives us answer choice D. On this problem, I'm given the derivative of some f function right here. Here's f prime. We want to know where the original function f is decreasing on the interval from -4 to 3. So first I need to find some critical values, and then I need to figure out where f prime is negative. So I'm going to start by setting this f prime here equal to 0. And this is a calculator problem, so I'm actually going to figure this out, what those intersections are, on the calculator now. So here I am on my calculator. I've entered my f prime here into my y1, and I need to figure out the window to graph this on. I'm going to use -4 to 3, because that's the only interval that they care about. So let me go to Window, -4 to 3, and then let me do Zoom 0, Zoom Fit. And this should hopefully give us a nice little window on this function. So there's f prime. We see there are multiple x-intercepts, and we want to know all of them. So let's go ahead and use, let's see here, second trace. And I'm going to go with 0, option 2. And let's see here, let me move my spider. We'll start on the far left here. So a little bit to the left of this first intersection. Press enter. A little bit to the right. Press enter. Press enter again. And that's going to be about -3.444. So here's the graph. First intersection is this. And we're going to do 3 more of these. I'm going to do those off camera. So if you find the intersection of these other 3, they end up being, this one here is going to be -1.806. This one ends up being about -0.660. And this last one is about 1.509. Okay, so now we're interested in where f prime is less than 0. If we're looking for decreasing for f, we want less than 0 for f prime. So f prime is going to be less than 0 on this second interval right here between, let's see here, this is -3.444 and -1.806. So f is going to be decreasing on this interval and also this other interval between -0.660 and +1.509. So that ends up being answer choice C. For this problem, we have a function defined as x ln of x for positive values of x, because plugging in 0 or negatives is going to make ln very unhappy. So we want to know on what interval f is decreasing. So we're looking for places then where f prime is negative. So that means we need to figure out what f prime actually looks like. So f prime, that's going to require us to use the product rule. So let me set up the box and ribbon to help me with that. I've got factors of x and ln of x. And then the derivatives are going to be 1 and 1 over x. Using the ribbon to multiply that together, I've got 1 times ln of x, so ln of x. And then plus x times 1 over x, which is just 1. And I need to solve for critical values here, so let me set this equal to 0. So if I subtract 1 and raise e to both sides, I end up with e to the negative 1 for the only x value that zeroes that out. And in terms of critical values, there are also values that make ln undefined, but they're going to be either 0 or negative numbers, and we've already excluded those. So let's do a little sign analysis now using this critical value of e to the negative 1. Here's my f prime number line. We're going from 0 to, well, infinity. And we have this critical value here at e to the negative 1. So at this point, all we have to do is figure out some values that we can plug in to test this. Now, this is a little bit tricky. I'm finding something between 0 and e to the negative 1 because we can't pick negative numbers. Those would be less than 0. So I'm going to go with e to the negative 2. And the reason I'm choosing this is because it's really easy, no pun intended, to plug into the ln function. ln of e to the negative 2 is just negative 2. So that means we have negative 2 plus 1, which is a negative number. And now something bigger than e to the negative 1. Let's go with e. That seems easy enough. ln of e is 1. That's going to be a positive then if I add 1 to that. So we see here that f prime is less than 0 between 0 and e to the negative 1, which means that f is decreasing on this interval. So let's see here. That's going to end up being choice A that we're decreasing on. On this problem, I'm given this f of x function here, which is a polynomial. We want to know on which intervals this is decreasing. So for that, I need to figure out where f prime is negative. Let me start by finding f prime. That's going to be, let's see here, using the power rule, 3 times 1/3 cancels out. So we just have x squared. This is going to be minus x, and then this will be minus 6. Let me set this equal to 0 and find some critical values. So factoring this, things that multiply to negative 6 and add up to negative 1, that would be x plus 2 and x minus 3. So we have x values then of negative 2 and positive 3. Let's put those on a number line, an f prime line. So here's negative 2 and 3 critical values. Let's test something in each of these intervals now, and I'll use this factored version of f prime. So something to the left of negative 2, let's try out negative 3. That gives me a negative times a negative, which is a positive. And let's see, 0 is a good number on this middle interval. That's a positive times a negative, coming out negative. Something bigger than 3, let's go with 4. Positive up here is going to give us positive over here. So we see here that f prime is less than 0, is negative on the interval from negative 2 to 3. Therefore, f itself is decreasing on negative 2 to 3, which is going to give us answer choice A. For this problem, I'm given the function f whose derivative is f prime equals this crazy looking function. And yeah, this is a calculator problem if the answer choices didn't spell that out for you. On which of the following intervals in 0 to 6 pi, that's kind of interesting, is f decreasing? So we want to know where this f prime function is negative. But first we have to figure out where it's 0. We need to find the critical values. So since they already gave me the function, I can just write f prime of x equals 0 in terms of showing work. And now I can find those intersections on my calculator. So here's my f prime that I've entered in y1. And for my window, I'm going to go with 0 to 6 pi. So let's see here. We've got 0 and then 6 pi. Enter that in. Okay. And let's do zoom 0 for the perfect window on this, zoom fit. So there's my f prime. And it looks like we are crossing in multiple places on that x-axis. So we know that we have a crossing. It looks like it's 0. And this next crossing, let's see what that's going to be. Let's do second trace. And 0's option 2. So let me move my spider to the left. I wish my spider moved faster, but hey, what can you do? All right, so we press enter, move a little bit to the right, press enter a third time, and we've got a 0 at 1.097. So there's the first intersection other than 0 itself. And now there's a few more intersections here. So if you find them on your own off camera, you will see that this next one here is about 4.386, followed by 9.870, and this last one is pretty close to 6 pi. This is 17.546. Okay, so we're really interested now that we've got a visual here in where this f prime graph is negative. So we see that that's going to be on this interval right here and this other interval over here. This first interval, where f prime is negative and therefore f is decreasing, that is the interval from 1.097 to 4.386. And then this next interval, that's from 9.870 to 17.546. So that ends up being, let's see here, out of all of these, it looks like answer choice C has the intervals we're looking for.